Hey there, everyone. Today, we're diving into a fascinating story about a scientific project that never quite made it to the finish line. It's the tale of the Superconducting Super Collider, a particle collider that was set to be the world's most powerful, but ended up being a 22.5 km tunnel hidden beneath Texas for over 3 decades. Now, this isn't just a story about a failed project. It's a tale of ambition, misunderstanding, and the challenges of scientific collaboration. So, let's get started. First things first, what makes this story so intriguing? Well, for starters, the Superconducting Super Collider was supposed to be a game changer. It was designed to smash protons together at unprecedented energies, allowing scientists to study the fundamental building blocks of matter in ways we'd never been able to before. Imagine being able to recreate the conditions of the early universe right here on Earth. But, as we'll see, the journey to making this happen was filled with twists and turns. Now, one thing that immediately stands out is the sheer scale of the project. The collider was supposed to be an 87 km long circular accelerator buried deep beneath Ellis County, south of Dallas. That's a lot of tunnel. And, as it turns out, a lot of money. Early estimates put the cost at around $4.4 billion, but as construction progressed, those estimates kept climbing, eventually reaching over $11 billion. So, what happened? Why did the project go over budget? Well, in my opinion, it's a classic case of scope creep. As engineers refined their calculations and made technical revisions, they realized they needed more equipment, more magnets, and more detectors. And, of course, all that came with a price tag. But it's not just about the money. The project also faced challenges in terms of international collaboration. The plan was to make the collider an international scientific partnership, with foreign governments chipping in billions. But, as it turns out, getting countries to commit to such a massive project wasn't easy. India pledged support, but larger contributions never materialized. European governments were already pouring resources into CERN, and discussions with Japan got tangled up in political and trade issues. By the time serious attempts were made to attract major international investment, many of the project's key decisions had already been made, leaving potential partners with little influence over its design or direction. So, what does this tell us about scientific collaboration? Well, in my opinion, it highlights the challenges of managing expectations and keeping projects on track. Now, one thing that many people don't realize is that the Superconducting Super Collider's cancellation wasn't just about the money. It was also about the broader economic climate. During the early 1990s, federal budgets were under pressure from competing demands, and as projected costs continued to rise, support within Congress weakened. So, what does this tell us about the politics of science? Well, in my opinion, it shows how scientific projects can be vulnerable to shifts in political priorities and public opinion. But let's not forget the silver lining. Even though the Superconducting Super Collider never became operational, its scientific ambitions didn't disappear. Years later, CERN's Large Hadron Collider in Switzerland and France entered service, and in 2012, scientists working on the ATLAS and CMS experiments announced the discovery of a particle consistent with the Higgs boson, confirming one of the central predictions of modern particle physics. So, what does this tell us about the legacy of the Superconducting Super Collider? Well, in my opinion, it shows that even when a project doesn't pan out, its scientific goals can still be achieved through other means. Now, one detail I find fascinating is the fate of the tunnels. The unfinished infrastructure has never served its intended purpose. Access shafts were eventually sealed, and sections of the underground tunnels filled with water over time. Without the accelerator equipment that was meant to occupy them, the passages remain empty beneath the Texas landscape. Above ground, little suggests that one of the world's largest scientific construction projects once stood there. But beneath the fields, more than 22 kilometers of tunnel continue to mark the abandoned foundations of a machine that was designed to push the limits of particle physics, but never accelerated a single proton. So, what does this all tell us? Well, in my opinion, It's a reminder of the challenges of scientific collaboration, the importance of managing expectations, and the resilience of scientific ambition. Even when a project doesn't pan out, its legacy can still be felt in the work that follows. And who knows? Maybe one day, we'll see a new collider rise from the depths of Texas, pushing the boundaries of our understanding of the universe. But for now, that's all I've got. Thanks for watching, and I'll see you next time.